Okay, first, what I want to do is to explain that this is a collaboration with people from mechatronics, because actually I'm not a person who works in mechatronics, but in control and in gait analysis. So the first question that we have to have in this case is why build a robot? Because this is a work about building a robot. I'm not into that. So my motivation is the following. I mean, building a robot is quite hard and it takes time, and usually you can publish that much in the field if you're not an expert. So the need to have this kind of robot is because we've been working with people with a target population in this field for years, and our target population is people who cannot walk by themselves and require a rollator for ambulation. And we found that we had a big problem using robots for these people. And the problems can be briefed as this. The most useful trouble with the smart rollators, of course, is that they are expensive, and not only you have to purchase them, but also you have to pay a yearly fee. And you know that research funds are scarce usually, and you cannot be guaranteed that you'll have money from one year to the next. So having a commercial rollator was quite difficult for us. But also it was harder even to work with these rollators because they are usually closed systems. I mean, if you need to add some sensors or some kind of actuator, or you need to modify them anyway, it's actually very hard. You cannot access to the hardware, and if you hack them, well, they are not so safe anymore. Also, from the point of view of our target population, we found that configuring them to their preference is not easy. They need someone, usually they need a clinician and also an engineer to prepare tests, and it takes a long time. And in the end, we found that the population didn't like to use these walkers because they don't look like their walkers. Even that they have trouble when they are used to one walker, to their own walker, they have trouble to move to another. So just changing to these very high-tech walkers, it was a problem for them. So in brief, our tests were very limited to specific situations with specific people for a very short time period. And we wanted to avoid this, so we thought maybe we can build a structure that will be more useful to this respect. Of course, building this kind of structures is not easy because it also takes time. And also we want to avoid software and hardware dependencies because usually some components are not available anymore, or some kind of software goes out of date and you're out of the walker. But especially we had three issues with standardization, ergonomy, and certification when working with patients, because it's not easy to have your tests approved by an ethical committee if your device is not certified. So in order to cope with these issues, we established some guidelines for design, which were mainly, first, we wanted to use common off-the-shelf technology when possible, not to develop anything too specific, but to use things that you can buy and also you can replace easily. I mean, if you're going to use a component, be sure that there are alternative companies that sell the same components, so you don't go out of market. Also, we plan to use open hardware and software for obvious reasons. And in order to cope with the three final problems, we decided to go for a modular system, meaning that we wanted to buy any rollator, any commercial rollator, not robotized in a shop, and then just put the technology on top of that as simple as possible on a need basis. So these were our requirements. And once we had these requirements, we had to think about what kind of small walkers we should buy. As you all know, initially walkers were basically robots, autonomous robots, and they moved on their own, and they just ambulated, and people could support their weight on them, but they didn't need people to move around. But recently, the tendency is to just use passive walkers or passive rollators, meaning that they won't move unless a person is pushing them in order not to upset their balance. And also you can appreciate that right now current rollators look more than like a rollators than before. So this is what we wanted to build in the end. And we just did a research of the state of the art to see what kind of sensors, what kind of hardware is required to have a robot like this. So we did this study of the last decade of smart rollators. We published it here in case you're interested in reading it. And we studied a number of features to see the common points and the difference between the most recent rollators. And actually, what we found out was that most of them required some kind of measurement of force. Most of them relied on how we support force on the handlebars. Also, that they have a low invasiveness. People don't like to wear things, don't like to be burdened by extra things. We are talking about the population who have trouble walking by themselves, so they don't want any extra burden, right? And we also found that there are different types of models, and the different types have different costs. This does not come as a surprise because my colleague before commented this also before, right? So what we needed was something to just measure weight on the handlebars, right? Because we want to measure steering and see where people want to go. And we also want a low-cost walker. So keeping this in mind, we designed this walk kit, which is a modular system that you can attach to any commercial device. I mean, we've tried already with different rollators, different commercial rollators that we bought for 100 euros, right? And what we added here was strain gauges on the handlebars to measure the weight that people bear in each handlebar, you see here. We also added odometry to the wheels. And in case we wanted to steer the patient one way or another, since the walker is supposed to be passive, we just brake the wheels selectively. So we have this module here, which is a motor, which just pulls the brakes from one wheel or another to steer if necessary. I mean, these devices can be just for monitorization or also for assistance. In case we don't want assistance, we can remove this module, but this is the basic structure of our kit. And something that I want to call your attention to is that everything is external. Every module can be attached externally. So the idea is that they are very simple to modify and to replace. And we are controlling everything with a Raspberry Pi, but we can control it with anything that can run ROS. Because another thing is that we probably want to add more modules on a need basis, more sensors or more devices or whatever. And here is as simple as adding something to a ROS robot. So this is our basic scheme. And this is one of our implementations. We've built like 3 robots this way thus far, and they are like, as long as we are building them, they are like 300 euros, including the frame that we buy. And you can see here, I mean, the wheelchair and the wheel odometry, and also the strain gauges that we put on the handlebars, and also the control system. You can see that everything goes on USB at the moment. And we don't need anything. We have a power bank for feeding, and that's it. I mean, the rollator looks very much like a conventional rollator, except for these settings, but they don't modify their weight or their consistency or anything in the structure, so it's pretty much like any other walker for people. Inside, we are running ROS, of course. This is the current implementation, also uses a laser, because the way that we are measuring gait here is by calculating the differences of the weight that we bear on one handlebar and another. So peaks are the instance where we put all our weight on one foot or another. But in some cases, people are not putting a lot of weight on the handlebars. For example, think of Parkinsonian. They just want it for balance, but they don't put that much weight. So in these cases, we have a laser that can also scan feet if necessary. We could just remove the odometry or remove the laser and they would work, but in using both, we have the redundancy. We have also a publication on the whole system, which is here, in case you are interested in this implementation. And what I think it could be of more interest to you is that everything is open. We have decided to go open software, open hardware, not just because that way it's easier to share with the community, but also because it's easier for us as well. If we need a robot, a new robot, we don't have to build it ourselves. We can take it to any mechatronics place or any mechanic place and give them the schematics and ask for one or two rollators. So the whole software and hardware of the basic version, because on top of this, you'll want to build your own software, and we as well. But the whole basic version is here, even the plans for 3D printing of the boxes where we put the components. Keep in mind that any component can be replaced by a similar one. You don't need a Raspberry Pi if they are too expensive, but you have any other system that can run ROS, right? So once we have this, the next step is processing the data that we are capturing. At this time, we are making a very simple process, which is extract the information from the sensors, and then we proceed to gait analysis based on what we already commented, which is when we are walking, the stages of gait, it means that we are putting our weight first on one leg and then on another. Any weight that we are not putting on our legs, we are putting on the handlebars. So with that, we can calculate the number of parameters of the gait, which are of interest. They are briefed here, like, for example, the length of our step, the time of our step, how much weight we are bearing here or there. These are parameters that are reportedly of interest for clinicians. And indeed, there are also reports of how these parameters affect gait for people depending on the conditions that they have. With reference to healthy gait, we have different conditions and how parameters grow or decrease depending on this. We also published in a previous IROS conference a work on this, if you are interested in seeing how we measure these parameters and how they affect different people depending on their condition. And also, I would like to offer this data set that we capture in elderly people care facility, Macrosat in Malaga. These are experiments that we perform with several volunteers. They are all elderly people, and they all need a walker to support their weight on. So we capture, using our system, we capture all the information, and we store it in raw format, so you can process it later. And we also added some wearables, simple wearables, and Empatica to see their state of stress while they were using their own walker, their own rollator, and ours. And everything is stored in a ROSBAC and also in CSV in case you are interested in processing we have already checked and the data is correct, and we managed to get the parameters that we were looking for. So you can play with this data set as much as you want. And it's interesting always to test your algorithms with the target population, because we healthy people do not walk the same, and sometimes it leads to error when we are testing things with people in our labs. Of course, you have to start in your labs, but later, right? So given this, now that we have the basis of the work that we are trying to do, now that we have the tools, we are interested in working further on monitorization and specifically on fall prediction. We are going to add extra sensors if necessary, and our idea is to calculate how likely a person is going to fall depending on the command that they are taking, and then affecting that command using the walker. And the idea is that if what I'm trying to do is going to upset my balance, the walker will try to avoid that by braking selectively one wheel or the other. And in that sense, we are also interested in share control. And the problem with share control is that people and device have to agree on what to do, because they are working at the same time. So any failure in this is going to upset balance. So basically, this is what we are trying to do, to calculate balance and to add this to our share control equation. So this is all I have for you, because I have a video, but it's better that we move to questions and you have some time for coffee, I think, whatever you prefer. Thank you very much for your attention.